Hey everyone, welcome back to class. Right before break, we learned how to solve quadratics by factoring. There were lots of different kinds. We had difference of squares, we had simple trinomials, complex trinomials, taking out a greatest common factor. But that's only one way you can solve quadratics, and that does not work every time. So there are three other methods to solve quadratics. We have by using square roots, by completing the square, and by using the quadratic formula. By the end of this week, you should be able to do all of those. Today we're going to be working on solving quadratics by using square roots. Before we get going on that, we need to make sure that we can simplify square roots. So we're going to practice that first before we actually get solving the quadratics. Alright, so there's some vocabulary I'm going to be referring to that we need to know.
Mr. Mike Johnson, please call the office 4581. Mr. Mike Johnson, 4581.
Okay, so a square root is only simplified if no radicand has a perfect square factor and there's no radical in the denominator. So what are those words? So radicand, right here, that is the number or term underneath the square root. That's the vocabulary word for what's underneath the square root. Okay, we normally refer to this as the square root sign, but more commonly or more generally it can be called the radical sign, because if I put a 3 there, that's a cube root. If I put a 4 there, that's a fourth root. Okay, so in general, this sign right here is called the radical sign. All right, so there are square roots that we already know how to take the square root of, hopefully, and those are perfect squares. For example, the square root of 9, that's asking you what times itself gives you 9, so the answer would be 3. Another example is the square root of 25. What times itself gives you 25? That answer is 5. Okay, but what about the square root of 8, right? There's an integer times itself that will give you 8, so how do I simplify that? And no, I do not want to put it in your calculator and get a decimal. We want to be able to simplify this. So I have what's called the jail method, where what you do is you do a factor tree for each of these numbers. So, and everybody from middle school should be able to do a factor tree. You think of two numbers that can multiply to be 8. So, for example, 2 times 4 would give you 8. And then you need to continue to break down this factor tree until you have all prime numbers, which are like 2, 3, 5, 7. So this 4 isn't prime, so it needs to be broken down into 2 and 2. Okay, in order to be able to escape what I call jail, which is the radical sign, okay, you have to have two numbers that are the same. So they buddy up and they try and escape jail together. But on the way out of jail, only one makes it out. So outside of the jail, we have one free to. And this poor guy right here didn't have a partner, so he's going to be still trapped in jail. So the square root of 8 can be simplified to be 2 square root of 2. Okay, I know this is new, so let's try another one. 27, two numbers that multiply to be 27, 3 and 9.
Miss Appling, call the office, please, 4581. Miss Appling, 4581.
Okay, 9 isn't a prime number, so we need to continue to break it down. Two numbers that multiply to be 9 are 3 and 3. So we end up with 3 3s here. Again, in order to be able to get outside the radical, there needs to be two numbers that are the same that can pair up and try and get out together, but only one of them will actually make it out. This poor guy, again, didn't have a partner, so he's still stuck in jail. So we get 3 square root of 3 is the answer for that one. Okay, let's try a number that's a little bigger, so 50. There's different ways, like you might think 5 times 10 are two numbers, which would be great and work great. I normally see if a 2 comes out of something first. So 2 times 25 will give you 50. And then 25, of course, can be broken down. That's 5 times 5. 2, 5, and 5 are all prime numbers, so we're done with our factor tree. And I'm looking for any two numbers that they're the same. So I see 2 5s. So they can pair up and try and make their way out, but again, only one makes its way out. And this 2 is still stuck inside. Okay? Alright, so 72 is a little bigger. Again, there's quite a few things that multiply to be 72. You could start with 8 times 9. Again, since it's an even number, I'm just going to take a 2 out first. 72 divided by 2 is 36. 36 can be broken down into 6 times 6, or again, I can just, it's even, so I can take out a 2 again. I'm going to continue to take out a 2, get 2 and 9, and 3 and 3. And the reason I do it this way is because it keeps it very organized. I'll show you kind of if you did the other way. 8 times 9, which is fine. Okay. A lot of times when people do it and it looks like this, they tend to miss things because there's numbers all over the place. So I kind of like taking out a 2 until I can't anymore, and then a 3 until I can't anymore, and then a 5 just to keep it organized so you don't miss any numbers. But this is fine. You'll notice you still end up with 3 2s and 2 3s. So, all right, so we're going to